So here's the individual muscle fiber. Here's the synaptic terminal, or the terminal bouton. And typically when we talk about the neuromuscular junction, the synaptic terminal of the motor neuron is so large, usually it is referred to as the terminal bouton, or it means terminal button. And that's a special term for the motor neuron because it is a gigantic synaptic terminal.
Compared to other ones?
Yeah, compared to like synaptic terminals in the central nervous system.
Okay.
So let's walk through the steps that occur at the neuromuscular junction. So again, a lot of this you have seen before, probably in anatomy. But there are 9 steps. We'll just break them down and kind of follow the book. So this image is from your textbook. So the first thing that we're going to have, so just looking at all the structures involved. So here's our terminal bouton. Here's our synaptic cleft. Here's the motor end plate of the skeletal muscle fiber. So here we're looking at the sarcomeres down here. Within the terminal bouton, we have the synaptic vesicles that house the neurotransmitter. We have voltage-gated calcium channels that are important for allowing exocytosis. On the motor end plate, we have the nicotinic receptors that when they bind acetylcholine, they open, allowing sodium in. They also allow a little bit of potassium out. That's why we see sodium and potassium moving, sodium in and potassium out. But the ratio, it's much, much more sodium coming in, so it's always excitatory. Okay, so what we're going to have is we're going to have an action potential moving down the axon of the motor neuron. It's going to arrive in the terminal bouton, and it's going to open voltage-gated calcium channels. Calcium is going to influx into the synaptic terminal. And then step 3 here is we're going to have exocytosis of the neurotransmitter, which in this case is acetylcholine. Acetylcholine is going to diffuse across the cleft. It's going to bind to the nicotinic receptor on the motor end plate and open the channel. Sodium is going to enter into the motor end plate. And this initiates what is called the end plate potential. It was our 3rd type of graded potential that we talked about back in chapter 4. So an end plate potential is just a graded potential that occurs in the motor end plate. The end plate potentials are so large that one end plate potential causes an action potential in the muscle fiber. So if you remember in the neurons, the CNS neurons, it took like 20 graded potentials to sum before threshold was reached for the action potential. But in the muscle fiber, it's just one end plate potential will lead to action potentials. So sodium comes in, all of this depolarizing current is going to lead to the opening of voltage-gated sodium channels. And that is what's going to start our action potential in the skeletal muscle fiber. So the action potential, voltage-gated sodium channels are going to open, sodium is going to flood in, creating an action potential, and then the action potential is going to propagate both directions down that skeletal muscle fiber. And then the last thing that is going to happen is on the motor end plate, we have that enzyme that breaks down acetylcholine esterase. So the final step listed here is the acetylcholine esterase breaking down the remaining acetylcholine so that it doesn't continue to stimulate this muscle to contract. So if we're looking at the skeletal muscle fiber there, so we have the motor end plate. So the sodium coming in here is going to stimulate action potentials traveling down the sarcolemma in both directions. And then on Wednesday, what we'll pick up with is looking at how the action potential fired by the skeletal muscle fiber leads to contraction. And we'll talk about that some next door when we do the skeletal muscle lab. So when we're working next door in lab, we're going to be